Everybody, this is Miss McClellan here to go over notes 4.2.4 with you. And today we'll be doing applications with the trig functions we've developed. So for our little intro, it says, throughout our chapter, we've developed new tools to help us determine the length of any side or the measure of any angle for a right triangle. Trigonometric ratios, as well as the Pythagorean theorem, give us the powerful ability to solve problems involving right triangles. Today, we will apply this knowledge to solve some everyday situations. Okay, so we have just one learning goal, and I'll write it in first person. I will be able to use sine, cosine, tangent, and the Pythagorean theorem to solve story problems. Period. Okay, first problem. David and Emily are climbing El Capitan, a big cliff. Let's look up a picture of it. This is El Capitan. It's a big rock face in Northern California. It's made of granite, which is it's made of granite, which is a volcanic rock that is very hard, and over millions of years, wind and water causes erosion, which pushes away dirt and soft sediment, leaving just the cliff. Anyway, David and Emily are climbing it. David is on the ground holding the rope attached to a carabiner. It's a pulley on the wall. I'll show you a picture of that too. Rock climbing carabiner. That's what it looks like. And it keeps you safe when you're climbing. When Emily stops to rest, David wonders, how high has she climbed? The rope is attached to his waist about 3 feet off the ground. Attached to his waist, about 3 feet off the ground. And he has let out 48 feet of rope, which goes up to the carabiner. And then back down the wall to Emily's harness. The rope at David's waist makes a 55-degree angle with the ground, and he is standing 20 feet away from the base of the wall. So in order to solve story problems, it's very helpful, everybody, to draw the situation at hand. And in this case, we're trying to find how high up the wall Emily has climbed. And we have a couple of steps along the way that should help us get there. So I'm going to draw the situation. And the drawing is really the hardest part of the problem. So I encourage you to pause and try on your own to draw this. Okay, here is David. The rope is waist high and it's 3 feet off the ground. Okay, I'm going to zoom into the drawing. It looks like it says 13 feet. I don't mean for that to be the case. Let me try to make it more obvious that I'm just talking about that distance. 3 feet off the ground. And David is standing 20 feet from the cliff. And the rope, which is attached to the carabiner, makes an angle of 55 degrees with David's waist. And the carabiner pulls the rope, which goes back down to Emily. And here is Emily. And the height that she has climbed is right here. Now the rope is, let's see, we've taken care of this piece of information 20 feet away. We've used this feet, 55, 48 feet of rope. So here and around the carabiner, that's 44 feet of rope. And we're assuming there's no slack in the rope. The rope is tight. And we're trying to find this little piece of our drawing. All right, I'm satisfied that I've done what I can with this drawing. Let's look at part A. Assuming that the rope is tight, approximately how long is the rope between David and the carabiner above Emily? So I'm being asked to solve for this part of my little triangle here. I've got a right angle because the cliff is presumed to be perpendicular to the ground, 55-degree angle between his waist and the carabiner. Okay. And the question is, how long is this section of rope? Well, I know that David is standing 20 feet away. And so I have a situation where I have cosine because I have the adjacent side of a triangle and the hypotenuse. So I'm going to say cosine of 55 degrees equals 20 over x, and then I'll cross multiply and solve for x. Okay, that means that x times cosine of 55 is 20, and I divide both sides by cosine of 55. And I get that x is equal to I think 34.8690 if the answer key I made is right, but I'm just going to redo the calculation. 20 divided by cosine of 55 degrees. 34.869. Very good. So x is 34.869 feet. Oh. It would really make more sense for us to just say 35, but I'm using the decimals because that's what my calculator gave me. All right. And I'm wondering, for part B, how high up Emily has climbed. So I know that this distance is 20. This distance is 3. This is 34.87 about. And Emily has climbed this part. And this part is equal to the length of the rope minus the hypotenuse, because the rope goes the hypotenuse and then down again to Emily. So 44 minus 34.87, which is 9.13 feet. Okay. So now, everybody, you just get to watch me think. I'm going to solve for this side of my triangle. This length is equal to, well, I'll use tan to find it. So tan of 55 equals that length over 20. I'll multiply both sides by 20, cross multiply, and I'll get that that length is 20 times tan of 55. which is 28.56. Okay, so now I know that the whole side of the triangle is 28.56, but what I'm interested is in the little piece of the triangle down here, which would be 28.56 minus the 9.13 feet of rope. So I'll take away 9.13. And that gets me 19 feet for this part of the triangle. But I'm not done because I need to add the 3 feet that is below the triangle, because recall, my triangle is actually floating 3 feet above the ground. And I want to know how high Emily went. And Emily didn't start climbing 3 feet above the ground. That's just where our triangle starts. So I need to add 3 feet to this. So 19.43 plus 3. Equals 22.43 feet above the ground. That's how high Emily has climbed. Okay. I'll just make it obvious that that little number is the answer. 22.43 feet. There are a lot of ways to do this problem. What you've just witnessed is my thinking process, but your thinking process is just without. And it's probably a little bit different because this is a really nice problem that has many, many solution methods. Either way, you'd be using tan, cosine, maybe a little bit of sine. It depends where you want to put your angle. You could also use Pythagorean theorem for part of it. Okay. The Bungling Brothers circus is in town, and you are part of the crew that is setting up its enormous tent. The central pole that holds up the tent is 70 feet tall. I'm going to look up a picture of a circus tent. With a center pole. A circus tent with a center pole. This kind of works. This one. There's a center pole, and the pieces go down on one side. So it has a center pole. It's 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. This is the angle with the ground, and it's 60 degrees. How long is the cable? How long is this cable? Well, I can do that with sine because I have opposite and hypotenuse. So sine of 60 degrees is equal to 70 over x, and I will cross multiply. That gets me that x times sine of 60 degrees is equal to 70, and I'll divide both sides by sine of 60 to get x alone, which has x is equal to, and I'll throw that in my calculator, 70 divided by sine of 60, which is about 80.8 feet. Box it. Okay, part B. How far from the pole should the cable be attached to the ground? So now I'm wondering what this length is. I'll call it Y. So now I will be using tangent because I want to use that 70 in the Y. I can also do this with cosine because we just solved for X, so X is no longer unknown. All right, so I'm going to use tan. Tan of Y, tan of 60 equals opposite over adjacent, so 70 over Y. I multiply both sides by Y, cross multiply. Y times tan of 60 equals 70 times 1, which is just 70. I divide both sides by tan of 60 to get Y alone. And I get that Y is about equal to, well, let's see, 70 divided by tan of 60. It's about 40.1 feet. Okay, that's this page. Next page. Okay, 4-91. Nathan is standing out in a meadow. Isn't that nice? What's a meadow look like? Here are some pictures of meadows. So Nathan is standing in a meadow exactly 185 feet from the base of El Capitan. And at 11 o'clock a.m., he sees Emily climbing up the wall and determines that his angle of sight up to Emily is about 10 degrees. Let's make a drawing. Part A. If Nathan's eyes are about 6 feet above the ground, how high is Emily at 11 a.m.? Okay, so here's Nathan. Here's Nathan's eyes. Nathan is 185 feet from El Capitan, and the triangle we're drawing is 6 feet above the ground. All right. And we're being asked, how high is Emily? And he's looking right at her at 11 a.m. So to solve this, I will figure out this distance right here. I'll call it X. And then I will add 6 feet to it because the triangle is floating 6 feet above the ground. Okay. This is a 10-degree angle because Nathan's line of sight, Nathan's lining of sight up to Emily is 10 degrees above the horizontal. So to solve for X, I will use tangent because I have the opposite and adjacent part of a triangle. So tan of 10 degrees should be X over 185. I cross multiply. That gets me 185 times tan of 10 equals X. Okay, let's see. Calculator time. 185 times tan of 10, sorry. So X is about 32.6 feet. And that's not how high Emily is because Emily is 6 feet above that. So her total height above ground is X plus 6. So she is about 32 plus 6 is 38, 38.6 feet above the ground. Okay. Part B. Now it's 11:30 a.m. Time is passing. Emily has climbed some more, and Nathan's angle of sight to her is now 25 degrees. How far has Emily climbed in the past 30 minutes? Ooh. Okay. So let's look. I'm going to put the original, the new triangle. So this is now a 25-degree triangle. Here's Nathan. At 10, when the angle was just 10 degrees, I solved for the opposite side of my triangle, which was x, and it equaled 32.6 feet. The adjacent side length of the triangle was 20 feet. And now I'm wondering what this length right here is. So I will call this, I don't know, n for new. It doesn't really matter. Now I can solve for this whole distance, n plus x, using tangent again. Tan of 25 degrees should equal n plus x over 20 feet. All right, so let's see about that. I cross multiply. I have 20 times tan of 25 equals n plus x times 1, which is just n plus x. I know what x equals, so I have 20 times tan of 25 equals n plus 32.6 feet. I'm going to subtract 32.6 feet. Which gets me n is equal to 20 times tan of 25 minus 32.6 feet. And I'll put that directly into my calculator. Let me change the brightness so you can see. And zoom. 20 times tan of 25. Can you see? I hope so. Tan of 25, close parenthesis, minus 32.6. I must have made an error. Let me see here. Oh, ha ha ha. I'm thinking this is 20 feet. This is 180 feet, 185 feet. I'm not doing 20 times 10 to 25. I'm doing 185. 185. 185. 185. See? Okay, back to it. 185 times tan of 25, close parenthesis, minus 38.6. Nope, 32.6 equals 53.7. So n is about equal to 53.7. So Emily has climbed about 53.7 feet in the past 30 minutes. Period. Imagine trying to do this without a drawing. How would you do it? The drawings are really important. Okay, next question. Last for this page. If Emily climbs 32 feet higher in 10 more minutes, at what angle will Nathan have to look in order to see her? Okay, let's see. This is my new drawing. So, oops. This triangle will represent a 25-degree angle. Here's Nathan. That's his line of sight. My question is, what will this angle be if Emily climbs 32 more feet? So if she climbs 32 more feet, what will that new angle be? So in total, right here, I'll have 32 plus, I want to know if this length ratio is n plus x, which I can just get from doing 185 times tan of 25. 185 times tan of 25. So this height was 86.2 feet. So the total height of this right triangle is 32 plus 86.2. 32.6. So this whole height is 118.87 about feet. And my question is, what's the angle? Well, I can do that. No problem. And I'll be tan of my angle will equal opposite height, the opposite over the adjacent. So 118.87 divided by 185. And in order to solve this, because I'm trying to get the angle, I'm going to have to go backwards. I'll need to use inverse tangent. So this will be the inverse tan of my ratio equals my angle. And all I have to do is put that in the calculator. Let's see. 118.87 divided by 185. 32.72. The angle is about equal to 32.72. Now, when I did this problem last year, the year before, anyway, when I did this problem in previous years, I got the answer 32.6, which is just to say that depending on where and when you round, your answer will change slightly and you can still be correct. Because we're using approximate instead of exact answers throughout, we end up with rounding errors. And unless we are told exactly how to round, a range of rounding errors would be acceptable. So if you got 32.6 for your answer, it doesn't mean you're wrong. It just means you rounded in a different place than I did. All right, let's write this final answer in context. Nathan will have to look at a about 33-degree angle in order to see Emily. Period. All right. That's the end of the CPM problems, but we do still have more problems to do because I want you to be prepared, students, for anything that might come at you. And there are some vocabulary terms which we did not go over in this lesson. So we're going to do 1, 2, 3, 4, 5, 6 more problems. They're word problems and they can all be solved with the methods of this class. Okay. The only two new pieces of information we have and to do these problems are angle of elevation and angle of depression. Angle of elevation is up from a horizontal, angle of depression is down for a horizontal. That could make sense because elevation usually refers to how high somebody or something is, and depression usually refers to how low something is. So again, angle of elevation, how high you are from a horizontal line, angle of depression, the angle that you descend from the horizontal line. Let's do these problems. First problem. Okay. You might not be able to see this, but I'm reading it out loud and hopefully you have the worksheet in front of you. An airplane is flying at an altitude of 6,000 meters over the ocean directly towards the coastline. So I'm going to start my drawing. I've got an airplane. And it's flying at an altitude of 6,000 meters over the ocean directly towards the coastline. So the angle of depression to the coastline, so this angle here, because I'm going down, is 14 degrees. How far does it need to fly before it is directly above the coastline? So I feel like this is worded in a way that I find to be a little bit confusing, but I know that my elevation, my height is 6,000. And I'm assuming that I'm going to be above, not touching the coastline. So when it says directly towards the coastline, I think it means that the airplane is maintaining a height of 6,000 meters. In calculus, you could do this problem in such a way where we're not maintaining a certain height, but we're not there yet. This is, we don't have changing heights. So I'm going to treat this as though I know the problem means that the height is maintained at 6,000 meters above ground. And I'm going to solve for this part of my triangle X because I'm asking how far I have to fly horizontally to be above the coast. All right, so this is possible to do with tangent. I have tan of 14 is equal to the opposite side divided by the adjacent side. So equals 6,000 over X. I multiply both sides by, I cross multiply, so I have X times tan of 14 equals 6,000. And since I want to get X alone, I divide both sides by tan of 14. Which gets me that X is about equal to 24,065 meters, which I would take as the final answer, but do pay close attention. They're asking for kilometers, so I would just need to divide this answer by 1,000 because there are 1,000 meters in a kilometer. So my final answer is going to say 6,000, 24,000, 24 kilometers. Haha. X is about equal to 24 kilometers. That's rounded to the nearest kilometer. All right. Number 2. From a horizontal distance of 80 meters, the angle of elevation up to a flagpole. So here's 80 meters horizontally, talking about angle of elevation. So I'll be going up. Angle of elevation is 18 degrees. And we want to calculate the height of the flagpole. So what is this height? Again, I'll be using tan. Tan of 18 is equal to opposite over adjacent, x over 80. I cross multiply. I have 80 times tan of 18 equals x times 1, which is just x. And that I can put in my calculator immediately. Here I have x is about equal to, is this in meters? 26 meters. Okay, moving right along. Number 3, a 9-meter ladder rests against the side of a wall. So the ladder is 9 meters long. It's resting against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. Determine the measure of the angle between the ladder and the ground. So I want to know the measure of the angle between the ladder and the ground. And I will be using cosine because I have the adjacent side and the hypotenuse. So cosine of the angle should equal 1.5 divided by 9. And I'm being asked to find the angle. So I'm going to need to use inverse cosine to get from my ratio back to the angle. So the inverse cosine of 1.5 over 9 should equal my angle. I put that in my calculator and I get that my angle is about equal to 80 degrees because I'm rounding to the nearest degrees. There. Okay, 3 more problems. Number 4. The angle of elevation of the sun is 68 degrees. Okay, angle of elevation of the sun. So I've got angle of elevation. I have to be going up. That's 68 degrees. And that is when a tree casts a shadow 14.3 meters long. This is confusing. How tall is the tree to the nearest tenth of a meter? So I find this problem to be a little bit confusing because it's talking about angle of elevation, and why would this tree, oh, I see. The 14.3 meter long shadow is on this side of the tree. And we have to use symmetry to know that this is also 68 degrees. And I want to know the height of the tree. Okay, I'll be using tangent because I have the opposite and adjacent side. Tan of 68 degrees is equal to x over 14.3 meters. I cross multiply, I have 14.3 meters times tan of 68 equals x times 1, which is just x. And that gets me that x is about equal to 35 meters. So the tree is about 35 meters tall. Okay, 2 more problems. Number 5. A wheelchair ramp is 4.2 meters long. It rises 0.7 meters. What is its angle of inclination to the nearest degree? I wonder if it meets code. In order to meet code, it can be at most 4.12 degrees. Okay, let's check. Tan. It's not tan, sorry. It's cosine because I have the opposite, it's sine because I have the opposite side and the hypotenuse. So sine of my angle equals 0.7 meters divided by 4.2 meters. To find the measure of my angle, I'll use inverse sine. So theta equals inverse sine of 0.7 over 4.2 which equals, I'll put that on my calculator, 0.7 divided by 4. Oops, I need to do sine of that. Inverse sine. Inverse sine of 0.7 divided by 4.2. So my angle, rounded to the nearest degree, is about 10 degrees. That is way too steep. That's like double a safe angle. More than double. The angle shouldn't be more than 4.76 degrees in order to be safe. This would not meet code, and any relatives you may have who need a good wheelchair ramp would be in a bit of trouble. Anyway, next problem. A person flying a kite has released 176 meters of string. The string makes an angle of 27 degrees with the ground. So I have 176 meters of string, 27-degree angle with the ground. How high is the kite? X. How far away is the kite horizontally? Y. Answer to the nearest meter. So I'll be solving for both X and Y. So let's do X first. X we'll be using sine because I have my hypotenuse and my opposite side. So sine of 27 equals X over 176 meters. I cross multiply. I have 176 times sine of 27 equals X. So I put that in my calculator, 176 times sine of 27, and I get 79, about 80. Am I doing to the nearest meter? Yeah. So the kite is about 80 meters high, period. And let's also solve for how far away it is horizontally. So that's Y. And for Y, I'll use cosine because I have the adjacent and the hypotenuse. So cosine of 27 equals Y over 176 meters. I cross multiply, I get 176 times cosine of 27 equals Y times 1, which is just Y, and Y is about equal to 157 meters. So the kite is about 157 meters away horizontally. Okay, last problem. That was the last problem. What I hope for you to get from this lesson is that you should always draw a drawing, unless the problem is so obvious that you just don't need one, but that will be rare. The drawings are important, especially for clarity. Anyway, I hope you had a nice time. The next thing is the practice test. This was the last lesson, and I'll see you next time. Okay, bye.